sodium and glucose that couples that movement.
So should this picture have glucose on the outside?
Well, this picture is taken from a different area demonstration. So yeah, it's going to have glucose, either amino acids or glucose on both. So I'm really focusing on this image to show that the transport molecule associates with both. And we use amino acids on both. So here is the active transport of sodium, depleting the cell of sodium, increasing the drive from the filtrate side, so that when sodium moves down its concentration gradient, glucose, which fits on that same molecule, is pulled into the cell as well.
No, does that protein have a name, or is it?
It's just a transport, glucose transporter secondary. So is this an antiport or a symport?
Yeah, it's a symport.
So this would be a secondary transport protein. And it uses a symport because they're going in the same direction. All right. When the glucose gets to the basal membrane, it exits via facilitated diffusion. Now I put glucose here, but amino acids also have a secondary transport protein with sodium. There would be a different one. So you don't have both glucose and amino acids going in the same component. So the way you're reading this, it's glucose and amino acids, some ions, but primarily glucose and amino acids are coupled with the movement of sodium into the cell. So because we're going from filtrate to blood, this direction of movement is reabsorption. Unless glucose levels are really, really, really high, all of the glucose and all the amino acids will be reabsorbed from the filtrate of the proximal convoluted tubule. And when we get to the nephron loop, there will not be any glucose or amino acids left in the filtrate. Okay? Most of the sodium is reabsorbed, all right, and varying amounts of some of the other ions. But all the glucose and all the amino acids will be reabsorbed. Now, I don't know how many of you have taken a glucose challenge test. I bought some of this solution when I was teaching back east to give to my students for a urine lab, and we used it at Sac State. You can buy these small 6-ounce containers, 4 to 6-ounce containers of carbonated orange, that always are orange, but have high glucose. They're really sticky sweet, and you drink it as fast as you can, volume dependent on your body weight, and then they do a urine sample every so often. In the lab, we have the students go to the bathroom, not go to the bathroom when they get up in the morning, go to the bathroom when they get to class, and then drink this solution, and then every 30 minutes go to the bathroom, bring back their urine, and measure the glucose, and measure the specific gravity, and so on. We've gotten permission, the lab techs didn't want to work with body fluids, and so I've been on a campaign for the last 3 or 4 years saying, as faculty, we get to determine our labs. And so we have a new lab supervisor, so I've gotten that cleared. So starting next year, we'll be doing this lab. I'm giving you the similar numbers, so we will work with those numbers in the lab. Some students will drink cranberry juice, some drink this high sugar. I would hate to do it because I wouldn't want to drink 600 calories of sugar anyway. Others just drink distilled water. And at Sac State, I actually had students say, well, can we test the effects of alcohol? And I said, sure. You just can't bring the alcohol to the lab. And they do sell alcohol on campus at Sac State. So I said, come to the lab, go to the bathroom, and then go over to the student union or wherever it is, the restaurants there that they sell alcohol, and just measure how much you drink, and then come back to lab. You just can't bring alcohol to the lab because it's not allowed in the classroom. And you have better be 21 to do this. So, because alcohol does have an effect on ADH synthesis and urine formation. But it's going, so the term diabetes mellitus comes from the fact that individuals who have diabetes and have high levels of blood glucose do not have sufficient carriers to remove the glucose from their filtrate. At normal body levels of glucose, we do, and all the glucose is removed from the filtrate. It's an abnormal component of urine. But if you have high blood glucose, normal is 125 milligrams per deciliter, I believe. If you have 300, 500, which I've had some patients that have it that high, they have uncontrolled diabetes, then you're obviously not going to have enough of these transport molecules, and you're going to end up with glucose still in the blood. So the term diabetes mellitus stands for sweet urine. Sticking your finger in the urine and licking it is going to be sweet. Now I know that sounds gross. People actually have urine cleansing diets where they drink their own urine. However,
What about that Thursday?
is your blood sterile? It should be, unless you have sepsis. All right. Filtrate comes from the blood, so it should be sterile. It is stored in the bladder, unless you have a urinary tract infection, that should be sterile. So typically the urine is going to pick up any bacterial contents at the urethral opening. Okay? So if you're giving a urine sample and they want it sterile, they'll have you wipe that area with an antiseptic fabric or so on. And so just because it's waste material, we think of, you know, maybe it's just you don't want to lick something that has urea in it. But it really is, it came from your blood, okay? So it's like a cut and licking the blood off of your cut. Maybe that's gross too. But it's come from the blood, okay? Licking your CSF fluid if you ever had contact with it. So I know it sounds gross just because it's urine. My mom would always tell this story. When I was a kid in the Philippines, we would go to this one isolated beach every year with other families, and I got stung by jellyfish. And she had read, you pee on it. So she asked a good friend of, well, he was 10 years older than me, you know, here, take this cup and go around the rock and bring me back some of your urine. I'm 10, he's 20. He's like, no way am I doing that. So my dad came in from the ocean, and she told him, and being a good dad, he went around and brought back this cup of urine, poured it over my leg, and, you know, the urea takes care of the toxin effects, and that was fine. You know, she had to tell that story to her first aid class every year after year, so the entire community knew about this. And as a kid, that's like, Mom, really?
So it puts the pain away?
Yes.
Oh.
Neutralizes the toxins. Yes.
Coca-Cola or Pepsi takes the pain away better than
Then pee.
Really?
Unfortunately, we didn't have soda. So the only thing you could buy in the Philippines was lukewarm orange juice, primarily. But also vinegar has a similar kind of component to it. All right, so that is reabsorption.
Professor,
You could, yes.
while we're on it, why does it cause more dehydration when you drink our own urine?
Because it's already higher, it's like drinking seawater. So when you have someone who is caught, you know, isolated, shipwreck, and they start drinking salt water, that has a higher concentration of sodium, and so your body retains fluid to try to, or gets rid of the salt, and that affects it. Your body cells have less fluid available to them because of the higher salt concentration. Now, on page 12, you can also see that some substances are secreted. These same substances are filtered, but in an attempt to get rid of more, the body is going to transport from the filtrate from the blood back to the filtrate, and this is secretion.
A urine drug test. We can get that up.
So, broken down metabolites of antibiotics, okay? So, drug metabolites, one of the reasons why if you're on antibiotics, you have to take them every 4 to 6 to 12 hours, depending on the drug product. Urea. Pardon? Hydrogen ions. So on Friday, when we talk about acid-base balance, we'll talk about hydrogen ions.
That's why antibiotics make the yeast stink, huh?
Yeah. And we can make it orange too, or red, depending on the color. Now, hydrogen ions, as we'll see on Friday, will not cross the basal membrane of our cells. So how do we transport hydrogen ions? You're going to have an acidic pH. You lose hydrogen ions from the blood and gain hydrogen ions in the filtrate. How does that work if hydrogen ions cannot cross the basal membrane? You guys already know the answer. Carbonic acid. So remember, hydrogen ions couldn't leave the blood and get into the CSF? So instead, we transported carbon dioxide. Guess what these cells contain? The enzyme carbonic anhydrase. So we'll repeat that equation on Friday when we talk about acid-base balance. All right, so we're going to stop there. And on Thursday, we're going to look at what happens in the nephron loop. And we're going to look at what happens in the distal tubule when we regulate fluid and electrolyte balance. Okay? Now, at this point in time, so at this point, you can see up here, we've gotten to the proximal convoluted tubule. We have determined the content. Whatever is going to be present or absent in our filtrate has now been determined. What we haven't determined is the amount. So in the distal tubule and in the collecting duct, we are going to remove more of, or affect the movement of sodium, potassium, calcium, and water primarily. Some more or some less. But the content, whether it's there or not, has already been determined. Now we just will use hormones to increase or decrease that amount. Okay? If there's glucose still present when it leaves the proximal convoluted tubule, there's going to be glucose present in your urine. Okay? If there are amino acids still present, there's going to be amino acids in your urine. So it's primarily ions and water that we use hormones like ADH or aldosterone or parathyroid hormones to affect after this point. Okay, so today for lab, unfortunately,